Dear students, welcome back to a new mathematics session. In the previous session, we have discussed some of the basic concepts of trigonometric functions. Hope it was clear for you all. In today's session, we shall discuss problems from exercise 3.2. Let's move on to the topic. Before starting the session, let's have a quick review of what we have learned so far. In the last class, we have learned that cos 2n pi plus x is equal to cos x and sin 2n pi plus x is equal to sin x. This means that after every 2 pi rotation, the value will start repeating. After every 2 pi rotation, here n is an integer. After every 2 pi, means 2 pi, 4 pi, 6 pi, something like that. So after every 2 pi, the value will start repeating. Means cos 2n pi plus x means cos x. For example, cos 10 pi plus x is cos x. Sin 12 pi plus x is sin x. 12 pi means it is a multiple of 2. That's why that 12 pi can be considered as 0. So 0 plus x is x. That is what first we have learned in the last class. Next is sin x is equal to 0 implies x is equal to n pi. For every n pi angle, the sin value will be 0, where n is an integer, and cos x is equal to 0 implies x is equal to 2n plus 1 into pi by 2, where n is any integer. 2n plus 1 means it is a general form of an odd number. So this is what we have learned. Means for angles on x-axis, sin x is equal to 0, and for angles on the y-axis, cos x is equal to 0. Angles on the x-axis means there it will be pi, plus or minus 2 pi, 3 pi, and so on, and also 0 also will be coming. That is the angles on the x-axis. Then another way we can define this statement as for angles on the y-axis, cos x is equal to 0. For angles on the y-axis means it is plus or minus pi by 2, plus or minus 3 pi by 2, plus or minus 5 pi by 2, and so on. So these are all odd numbers, 1, 3, 5 and all. So that's why it is written as 2n plus 1 into pi by 2, where n is any integer. Then next one is sin x is equal to 0 implies x is equal to n pi, where n is any integer. This is the way we have defined the sine function. And cos x is equal to 0 implies x is equal to 2n plus 1 into pi by 2, where n is any integer. These two we have discussed before. And based on these two, other trigonometry functions also we have defined in the last class. That is tan x is equal to sin x by cos x. This is a rational function, means the denominator should not be equal to 0. Means cos x should not be equal to 2n plus 1 into pi by 2. That is the condition. The next is cosec x is the reciprocal of sin x. Denominator is sin x. Sin x should not be equal to 0. Then sin x should not be equal to 0 means x should not be equal to n pi. So x not equal to n pi, where n is an integer. Then sec x is the reciprocal of cos x. That is cos x should not be equal to 0 here, because cos x is in the denominator. Cos x is 0 is coming for these values, 2n plus 1 into pi by 2. So the condition is here x not equal to 2n plus 1 into pi by 2. Then finally the cot x is cos x by sin x, and the denominator if we check, it is sin x. Sin x will be 0 in x is equal to n pi cases. So here sin x should not be equal to 0 means x not equal to n pi, where n is any integer. Next, we have discussed about the table of values in terms of radians. Previously in class 10, we have learned these values in up to here. That means up to 90 degree we have discussed in terms of degrees. But here these values are converted into radians. 0 degree, 30 degree we have written as pi by 6 radians, means 180 by 6 is 30. Then 180 by 4 is 45. 180 by 3 is 60. Then 180 by 2 is 90. That is the way we have converted into radians. And these pi, 3 pi by 2 and 2 pi we have learned this year. So these values we have discussed. Sin 0 is 0, sin pi by 6 is 1 by 2, sin pi by 4 that is 45, that is 1 by root 2, sin pi by 3 that is 60 degree, that is root 3 by 2, sin 90 degree, that is 1. Then sin pi is 0, sin 3 pi by 2 is minus 1, sin 2 pi is 0. Similar way we have defined this cos and tan values. Once sin and cos is there means we can define all the other trigonometric functions. Sin and cos, sin by cos is tan, and cosec if you want to take the reciprocal of sin, sec if you want to calculate take the reciprocal of cos, and cot if you want to calculate take the reciprocal of tan. Next we shall discuss the sign of trigonometric functions. For that, let's take a unit circle like before, and if you take a point from here, the angle in which that particular point makes with the x-axis is 0, and this point is moves along the circumference of this unit circle. When it reaches here, the angle becomes pi by 2, and from here it turns and come back here, means the angle becomes 180 degree, that means pi. And from here, if it comes to this y-axis negative side, it comes as 3 pi by 2 angle. And when you take this point, move along the circumference of the circle, and when it reaches here in the starting point, that means 2 pi, means 360 degree rotation is completed. And as we know that here the angle, means in the first quadrant the angle is between 0 and pi by 2. You can we have already discussed this one previously. We have taken a point from here from 0 degree, and when it reaches here up to pi by 2 will be coming. So the angle is 0 less than x less than pi by 2. X is the angle. And in the second quadrant, when you check, it is pi by 2 less than x less than pi from here to here. And from the third quadrant, if you check, from pi to 3 pi by 2, that means pi less than x less than 3 pi by 2. And in the fourth quadrant, from 3 pi by 2 2 pi, so 3 pi by 2 less than x less than 2 pi. From 0 we have started, and once you completed the 360 degree rotation, one full circle rotation, the angle changes to 2 pi. So the fourth quadrant, it becomes 3 pi by 2 less than x less than 2 pi. Quadrants, we have already learned this one in class 9. Quadrants means when this xy plane is coming into this unit circle, or in this plane itself, it is divided into 4 quadrants, 4 pieces. This is the first quadrant, this is the second quadrant, this is the third quadrant, and fourth quadrant. When x and y axes are coming to the plane, then the plane is divided into 4 parts. First part is first quadrant, that is this one. Here it is the second quadrant, here it is third, and here it is fourth. I hope all of you are well aware of these quadrants. And in the first quadrant, both the coordinates, that is x value as well as y value, both are positive. Means you can see here, this portion x axis this side is positive values, and y axis this value is also positive values. So both x coordinate and y coordinate will be positive. And in the second quadrant, if you come, x value will be negative, means this is the negative side of the x axis, and this is the positive side of the y axis, that means y value will be positive. And in the third quadrant, if you comes, this is x-axis negative side, and this is y-axis negative side, means both x and y coordinates will be negative. And then when you come to the fourth quadrant, x value will be positive, because it includes the positive side of the x-axis and the negative side of y-axis, means positive and negative. X coordinate will be positive and y coordinate will be negative. These are all the basics of the quadrants. And then, as before, if you take a point on the circumference of the unit circle, that is cos x sin x, x is the angle in which that a particular point makes along the positive direction of the x-axis, and this is cos x sin x. Since it lies in the first quadrant, cos x is positive and sin x is positive. Cos function also positive, sin function also positive. Since cos and sine is positive, all the other trigonometric ratios are connected with the cos and sine. Tan if you take, it is sin x by cos x. Cosec if you take, it is reciprocal of sin x. Sec x if you take, reciprocal of cos x. Tan x if you take, cot x if you take, reciprocal of tan x. Because of that, all the trigonometric functions are positive here, since sin x and cos x are positive. And if you take this point and bring here, that means in the second quadrant, this point will come as minus cos x and plus sin x. Minus cos x means this is the x coordinate. X coordinate comes from this portion, negative side of the x axis. That's why the first coordinate, that is x value, is negative and y value is positive. Then here, if you check, cos x is negative and sin x is positive, means just consider the positive ones only. Negative ones just simply leave it. Positive ones, if you take, sin x is positive, means among the 6 trigonometric functions, sin x positive means only cosec also will be positive. Means here, if you take, sin x and cosec x will be positive. Sin x and cosec x will be positive. And when you come to the third quadrant, if you bring this point here, the coordinates are minus cos x minus sin x, because this is the negative side of x-axis. That means whatever point you take from here, it will be negative, and this is the negative side of y-axis. If you take a point from here, it will be also negative. So both x coordinate and y coordinate will be negative. That means minus cos x minus sin x. Then if you check here, tan x and cot x are positive, because cos x and sin x negative means surely cosec x will be negative, sec x also will be negative. And tan, if you consider, it is sin x by cos x. Sin x by cos x means negative can be cancelled, so tan x will be positive. Since tan x is positive, surely its reciprocal cot x also positive. So in the third quadrant, tan x and cot x are positive. And in the fourth quadrant, if you take, the point will be coming here or anywhere in the third quadrant, and the coordinates will change as cos x means x value, the positive direction of x axis, that's why x is positive. So cos x is positive, and this portion is the negative side of the y axis, means y coordinate will be negative. That means it will be minus sin x. Means in the fourth quadrant, cos x and sec x will be positive, because here when we consider the positive value, only cos x is positive. Cos x positive means it's reciprocal, that is sec x. So cos x and sec x will be positive, the remaining are negative. So here in the first quadrant, all trigonometric functions are positive. In the second quadrant, sin x and cosec x positive. In the third quadrant, tan x and cot x positive. And in the fourth quadrant, cos x and sec x positive. So here this is the way how this sign convention is defined. So just go through it, because it will be useful. And when we summarize this one, this will be the table. In the first quadrant, sin x is positive, and in the second quadrant, sin x is positive, and in the third quadrant, sin x is negative, and in the fourth quadrant, sin x is negative. Likewise, cos x is defined, tan x is defined, cosec, sec and cot x all defined. And this is not necessary to memorize. There will be a short form for recalling the sign convention of these trigonometry functions that we will be discussing in the next slide. Next, we shall discuss about a short form which will be useful for recalling the sign convention of trigonometric functions. So just remember these four words, that is add sugar to coffee. So let's see in detail this one. So there are four quadrants, x-axis and y-axis are coming into the plane, means it will be divided, the plane will be divided into four quadrants. This is first, this is second, this is third, and this is fourth. In the first quadrant, all positive, means we use the word add to remember. Add means the first letter A we have to take, and all positive. And in the second quadrant, sign is positive. Sign is positive means we can use the word sugar. The first letter S stands for sign. So here sign is positive. Once a sign is positive means it's reciprocal, means cosec also will be positive here. When you come to the third quadrant, we have to use the word to, TO2. Then here T is the first word, stands for tan. So here tan is positive. Once tan is positive means surely its reciprocal cot also will be positive. When you come to the fourth quadrant, there we use the word coffee. And here C, first letter C stands for cos. Here cos is positive, because of that its reciprocal sec also will be positive. And just if you shorten that, you can just remember four letters ASTC, means add sugar to coffee. A stands for all trigonometric ratios, S stands for sine. Once the sine is taken, then surely cosec also will be coming. Then next is T, that means tan. Once tan is positive, surely cot also will be positive. And the last one is C. C stands for cos. Once cos is positive means sec also will be positive. Next, we will be discussing about two important formulae which will be useful for solving trigonometric functions questions. So as before, let's take a unit circle. Unit circle means having radius of 1 unit, and if you take a point here, that coordinates of that point will be cos x and sin x. Here x is the angle in which that particular point makes along the positive direction of x-axis. And since we are measuring it in anti-clockwise direction, this is x, means positive x. If you are measuring the same angle downwards, means clockwise direction, means it will be coming as negative x. If this is negative x, means here the coordinates if you take, that will be changing as cos of minus x and sine of minus x. Because here as we know that x is the angle, here our angle is minus x. Minus x means this will be changing as cos of minus x and sine of minus x. And consider a triangle. This, if you consider this as a triangle, and bottom also there is another triangle, means there are two triangles separately, congruent triangles we can say, and they are having the same base, means the measurement of the base will be same. Means if you consider this as x-axis, this will be a positive value, means this positive value will be equal to cos x, because that is the x coordinate. That means this cos of minus x if you consider this point, this can be written as this measurement. This is our positive value, that can be written as cos x. And if you measure this length, that means from the x-axis downwards, if you measure along the negative side of y-axis, that will be a negative value will be getting. That means if you take this one as, see for example, if it is 0 1 2 3, just for time being I'm using this 1 2 3, okay, since it is a unit circle we should not count like that, but for understanding purpose I am doing. Here it is 0, then this is -1 -2 -3, means this point will be written as -3, that means minus y value. Here y value is sin x, actually the y value will be sin x and this will be minus sin x. So this point, another way if you write, it will be cos x comma minus sin x. X coordinate will be cos x and y coordinate will be minus sin x. And previously we have written by using the angle, it is cos of minus x and sin of minus x. So literally these 2 points are representing the same point, means here the same point, but we have written in 2 different ways, that's all. That means we can say that the x coordinate is equal to the y coordinate, means since these 2 ordered pairs are equal, means their corresponding x coordinates and corresponding y coordinates will be equal, means cos of minus x will be equal to cos x and sin of minus x will be equal to minus sin x. These are the 2 important formulae, okay. So that is cos of minus x is equal to cos x and sin of minus x is equal to minus sin x. Please remember these formulas, and this derivation, it is just for understanding purpose, it is explained. Next we shall discuss the exercise problems. First question from exercise 3.2. Find the values of other 5 trigonometric functions if cos x is equal to -1/2, x lies in the third quadrant. Here cos x, one trigonometric function value is given to us. There are 6 trigonometric functions, out of that 1 is given, so we have to find out the remaining 5 trigonometric function values. And here x lies in the third quadrant. Let's recall the sign convention. Add sugar to coffee, means in the first quadrant all positive, second quadrant sine and cosec positive, third quadrant tan and cot positive, and fourth quadrant cos and sec positive. And here since x lies in the third quadrant, our x is lying in the third quadrant, in the third quadrant only tan will be positive, tan and cot will be positive, means sine cos are negative, means this cos x is equal to -1/2 is negative because it is in the third quadrant. In the third quadrant, please make sure that in the third quadrant tan only positive, tan positive means surely cot also will be positive. The remaining 4 trigonometric functions will be negative. So here it is given to us cos x is equal to -1/2. So we have to find out the other trigonometric ratios. First of all, let's find out sine. So sine and cos, there is a relation. By using identity we can write as sine square x plus cos square x is equal to 1. So here remember the identities are very useful here for solving the questions. If you know the identities, first go back and by heart those identities and then come and solve these questions. If you don't know the identities, this is merely useless to study or to solve, okay. Then here sine square x plus cos square x is equal to 1. Here cos value is there, let's substitute sine square x plus cos, that is -1/2 the whole square equal to 1. That is sine square x plus -1/2 square is 1/4, -1 square is 1, 2 square is 4 equal to 1. Take this 1/4 to the right side, sine square x is equal to 1 minus 1/4. Then when we take the LCM, sine square x is equal to common LCM if you take as 4 into 1, just multiply it, 4 into 1 minus 1, 4 minus 1 divided by 4, that is what when we take the common LCM. Next is sine square x is equal to 4 minus 1, 4 minus 1 is, we can see here it is 3 divided by 4, simple calculation. Then sine square x is equal to 3 means sine x will be root of 3/4, that is the usual way we write, but here we have to add one more symbol, that is plus or minus. So sin x is equal to plus or minus root of 3/4, and here sin x is equal to plus or minus root of 3. Root of 3 is in the numerator and root 4 we know that the value root 4 is 2. So sin x is equal to plus or minus root 3/2. Here it's showing 2 values, plus or minus root 3/2, but we will take only one value based on the sign convention. So here x lies in the third quadrant. Third quadrant means we know that only tan and cot will be positive, means the remaining trigonometric ratios, sine also included there in the remaining case. So sin x will be negative there. So x is negative, sin x is negative in the third quadrant. Means from here we will be taking only the negative value. Therefore, sin x is equal to minus root 3 by 2. Here there were two values, but from here we will take only negative value, minus root 3 by 2. So the first trigonometric ratio we have calculated. Then tan x. We know the formula in terms of sin and cos, because sin and cos are there with us now. That is equal to sin x. Sin x is minus root 3 by 2 by cos x is minus 1 by 2. So just as a fraction we can write. That is equal to, here you can see the calculation. Actually it is not necessary to show, but just for understanding purpose let's discuss it. And 2 cancel, and here minus also will be cancelled. Only we are having a root 3. So that is the answer here, root 3. Next is cosec x. Cosec x means 1 by sin x. As we have discussed before, once sin and cos is there means we can calculate all the other trigonometric ratios. Cosec x is equal to 1 by sin x. So here sin x value is there, minus root 3 by 2. That is equal to 1 divided by minus root 3 by 2. It is just a reciprocal writing time, we will get the answer. Take and write up down. Minus root 3 by 2 we can write as minus 2 by root 3. Next, sec x. Sec x is the reciprocal of cos x. Our cos x value is given to us minus 1 by 2. That means 1 divided by minus 1 by 2. When we take the reciprocal, it will be minus 2 by 1. Minus 2 by 1, we know that it is minus 2. Next, we will be going for cot x. Cot x is equal to reciprocal of tan x, 1 by tan x. So tan x is root 3. That means 1 by tan x will be 1 divided by root 3. So 1, 2, 3, 4 and 5. All the 5 trigonometric ratios values we have calculated. Next we shall discuss question number 2. Question is, find the values of other 5 trigonometric functions if cos x is equal to minus 1 by 2, x lies in the third quadrant. One trigonometric function value is given, that is cos x is minus 1 by 2. We are asked to find out the other 5 trigonometric functions. So x is in the third quadrant. This question is similar to the previous one, so we will be doing as homework. Then the second part, find the values of other 5 trigonometric functions if sin x is equal to 3 by 5, x lies in the second quadrant. Here sin x value is given to us and it is in the second quadrant. Since x lies in the second quadrant means here it is the second quadrant. Second quadrant, sin and cosec will be positive. The remaining all trigonometric functions will be negative. So here sin and cosec, keep it in mind. Then sin, since x is in second quadrant, here sin will be positive. So given sin value is 3 by 5. By using the identity sin square x plus cos square x is equal to 1, we will be calculating the value of cos x here. Sin x value we can substitute, that is 3 by 5 the whole square plus cos square x is equal to 1. From here cos square x is equal to 3 square is 9, 5 square is 25. Plus cos square x is equal to 1, that is cos square x is equal to this 9 by 25 will come to the right side. That comes as 1 minus 9 by 25. Then cos square x is equal to, when you take the common LCM, similar process only, just like the previous question. Calculation and all more or less it is same. 25 into 125 minus 9, that is the numerator, divided by 25. Then from here cos x we can calculate. Before that, just to do the calculation, 25 minus 9 we can write it as 16. 16 by 25. From here directly also you can come here, it's not a problem. Then cos x is equal to root of 16 by 25. Since we are taking root, there will be plus or minus. So plus or minus root of 16 by 25. And cos x is equal to root 16 we know, that is 4. Root 25 value is 5. Here plus or minus is there, means two values are there. But as per the condition we will be taking only one value. So here it is clear that it is there in the second quadrant. X is there in the second quadrant. Second quadrant means sin and cosec will be positive. That means as x is in the second quadrant, cos x is negative, because in the second quadrant only sin and cosec will be positive. Cos is surely negative. That means from here we will be taking only the negative value, positive value we can neglect. So cos x is equal to minus 4 by 5. So sin and cos we have got. Since sin and cos is there means we can calculate any trigonometric ratios. Tan x, that is sin x by cos x. So sin x we know that it is 3 by 5. Cos x we know that it is minus 4 by 5. 3 by 5 by minus 4 by 5. Then we will be getting 3 by 5. Division becomes multiplication. Take the reciprocal. Minus 4 by 5 becomes 5 by minus 4. And here 5 we can cancel and we will be getting as 3 by minus 4. Here itself we can cancel common denominator 5 and 5. 3 by minus 3 by 4 we can write, or 3 by minus 4, both same only. Just this is not mandatory. Here itself you can do the calculation. Next is cosec x. Cosec x is a reciprocal of sin x. 1 by sin x. Here sin x is 3 by 5. That is 1 divided by 3 by 5. 1 divided by 3 by 5 means take the reciprocal, that is 5 by 3. Next is sec x. Sec x is a reciprocal of cos x. Cos x means here we have calculated minus 4 by 5. That is 1 divided by minus 4 by 5. Here also 1 divided by means reciprocal. That's all. Just take and up down and write. That is, we can write it as directly minus 5 by 4. Minus 4 by 5 is the cos x value. Reciprocal, if you take, numerator and denominator will be interchanged. So 5 divided by minus 4. This is not a mandatory step, just for understanding purpose it is written. How it is means, 1 division is changed to multiplication, then reciprocal, 5 into minus 4. Just a lower class calculation, this one, for understanding purpose. Directly also we can write. Next is cot x. Cot x is 1 by tan x. We know the tan x value, that is minus 3 by 4. So 1 divided by minus 3 by 4, as before when we take the reciprocal, means 4 divided by 3. Minus sign also is there, minus 4 divided by 3. So these are the other trigonometric ratios we have calculated. Next we shall discuss question number 3. Find the values of other 5 trigonometric functions if cot x is equal to 3 by 4, x lies in the third quadrant. Here cot x value is given to us 3 by 4, and we are asked to find out the remaining 5 trigonometric functions values, and the given condition is x lies in the third quadrant. So here third quadrant means this is the one. In the third quadrant it is tan and cot are positive. The remaining trigonometric functions are negative there. So since x lies in the third quadrant, sin and cos will be negative and tan will be positive. So here tan we need to consider because we are asked to find out cot value. Here cot x is equal to 3 by 4, that is the given value, and we know the identities. Previously sin and cos, while giving time we have used the identity sin square x plus cos square x is equal to 1. Here in terms of cot x we have learned an identity, that is 1 plus cot square is equal to cosec square x. So 1 plus cot square x is equal to cosec square x. This is the identity we will use, and we will find out the value of cosec x here. Let's substitute it. 1 plus cot x value is 3 by 4 the whole square equal to cosec square x. And here calculation is there. 1 plus 3 square is 9, 4 square is 16. 1 plus 9 by 16 is equal to cosec square x. And when you take the LCM, 16 into 1, that is 16. 16 plus 9 is 25. 25 by 16 is equal to cosec square x. Here I have removed one step because it was an easy step, and here directly we can do the calculation. Let's learn that way of calculation. 16 into 1, 16. 16 plus 9 is 25. 25 by 16 is cosec square x. From here, just to reverse the equation, cosec square x is equal to 25 by 16. From here cosec x we can calculate, that is equal to plus or minus root of 25 by 16. And here root 25 is 5 and root 16 is 4. There is plus or minus 5 by 4. Even the two values are there for cosec x, but we will be considering only one value based on the quadrant. In which quadrant x lies? Here x lies in the third quadrant. There tan and cot will be positive, means the remaining remaining functions are negative there. That means as x lies in the third quadrant, sin x is negative in the third quadrant. Since the sin x is negative, directly we can write cosec x is also negative. And this step is actually not necessary, just for understanding purpose it is written. Sin x means reciprocal of cosec, that's why it is written. From here directly also we can write only tan and cot is positive, means cosec of course it is negative. Directly we can write, it's not a problem. Then cosec value is here minus 5 by 4 will be considered, and by using cosec value, and we have cot value also there, so we will be calculating the remaining trigonometric functions values. That part we will be doing as homework. Next we shall discuss the fourth question. Find the values of other 5 trigonometric functions if sec x is equal to 13 by 5, x lies in the fourth quadrant. Here sec x value is given and condition is x lies in the fourth quadrant. Here you can check in the fourth quadrant, first, second, third and fourth. Here fourth quadrant, and in fourth quadrant cos and sec will be positive. The remaining all will be negative. So since x lies in the fourth quadrant, cos will be positive. Cos and sec will be positive. Here we know that here sec is given to us. Sec is given means there is an identity connecting sec square x and tan square x. That means 1 plus tan square x is equal to sec square x. You must be well aware of that identities. By using identities only we are calculating the first trigonometric ratio. So just remember that 1 plus tan square x is equal to sec square x. From here 1 plus tan square x is equal to sec square x value is, when you substitute sec x, 13 by 5 the whole square. That is tan square x is equal to, take this plus 1 to the right side, it comes as 13 by 5 the whole square minus 1. That is tan square x is equal to 13 square is 169, 5 square is 25 minus 1. Take the LCM, tan square x is equal to, when you take 25 as common LCM, 169 minus 25 into 1 is 25. Here we need to multiply with the 25 because 1 is having no denominator. So if there is no denominator, we have to multiply with the common denominator. If there is a denominator, then no need to multiply. Same denominator means no need to multiply. So tan square x is equal to 169 minus 25 is 144, then divided by 25. Tan x is equal to plus or minus a root of 144 by 25, and when you take the square root, plus or minus 144 square root is 12, 25 square root is 5, plus or minus 12 by 5. Two values are there, but we will be taking only one value because x is in the fourth quadrant, means only cos and sec will be positive. All the other trigonometric ratios will be negative, means here we can consider only the negative value, positive value we can neglect. Since x lies in the fourth quadrant, tan x is negative in the fourth quadrant. So tan x will be minus 12 by 5. Once you get tan x, directly we can go for cot x because reciprocal of tan x, cot. So 1 by tan x, that is 1 divided by minus 12 by 5. When you take the reciprocal, take this denominator to the numerator. That is minus 5 by 12. The next is cos x is equal to reciprocal of sec x. Sec x is there 13 by 5. So 1 divided by 13 by 5, again take reciprocal, it comes as 5 by 13. Next is, we will be going for tan x equal to sin x by cos x formula, because we know sin and tan, we know cos and tan, sin we don't know. So there is a relation between sin, cos and tan, that is tan x is equal to sin by cos. Then when you cross multiply it, sin x we want, sin x is equal to cos x into tan x, cross multiplication. Then tan x value we know, that is minus 12 by 5 into cos x we have already calculated 5 by 13. Just to multiply it, here 5 we can cancel, the balance will be minus 12 by 13, minus 12 by 13. Next is cosec x. Cosec x means reciprocal of sin x. Reciprocal of sin x means 1 by sin x. That means reciprocal of this number, minus 12 by 13 reciprocal is interchange the numerator and denominator, means 13 minus 13 divided by 12. That is the value of cosec function. Move on to question number 5. Find the values of other 5 trigonometric functions if tan x is equal to minus 5 by 12, x lies in the second quadrant. Here tan x value is given to us, x lies in the second quadrant. Second quadrant means sin and cosec will be positive here. So since x lies in the second quadrant, sin x will be positive, but tan x and cos x will be negative. So other trigonometric ratios all will be negative other than sin and cosec. So we know that here tan is our ratio. So by using identities, there is a relation tan and sec. So 1 plus tan square x is equal to sec square x. Just to substitute the value of tan here, 1 plus tan value is minus 5 by 12 the whole square equal to sec square x. And let's do the calculation. 1 plus minus 5 square is 25, 12 square is 144. Minus 5 means minus 5 into minus 5, that is a square. Minus 5 into minus 5 is 25, and 12 into 12 is 144 equal to sec square x. Then let's take the LCM, common LCM as 144. It's quite familiar for us now because we have done a lot of calculation before also. 144 into 1 is 144 plus 25 by 144 equal to sec square x. 144 plus 25 is 169 by 144. 169 by 144 is sec square x. Then sec x is equal to plus or minus root of 169 by 144. And here root of 169 we know it is 13, and the root of 144 is, it is a square root of 12. 144 means, root 144 means 12. Root 169 means 13. Plus or minus value is there, but we will be considering only one value. Here x is in the second quadrant. Second quadrant means sin and cosec are positive. So sec is surely negative. So cos x is negative in the second quadrant. Likewise sec also negative. So next just write the sec x value, means minus 13 by 12 will be considered, plus 13 by 12 is neglected. Sec x is minus 13 divided by 12. Here cos x is negative in that second quadrant. It's not necessary to write. If you wish to write, or else directly we can go for this statement, sec x is negative, because we are going to write sec x value. Then cos x is 1 divided by sec x, reciprocal of sec, that is equal to 1 divided by minus 13 by 12. Reciprocal, if you write, take this denominator, write as numerator, that is minus 12 by 13. Next we will be going for cot x. Cot x is equal to 1 by tan x, reciprocal of tan x. And here tan x value is there, minus 5 by 12, that is 1 divided by minus 5 by 12. When you take the reciprocal, it comes as minus 12 divided by 5. Here you must be very familiar of taking the reciprocals as well as taking the LCMs and also using the identities. If these three calculations you know, this type of questions very easily we can solve. Next is tan x. Tan x is sin x by cos x, that is a formula. That is equal to sin x we want. Then sin x is equal to tan x into cos x. Previously we have done this type of calculation. Sin x means just to cross multiply it, tan x and cos x. That is tan x into cos x. That is equal to tan x, we have the value minus 5 by 12. Tan x value is minus 5 by 12. Then next is, it is given to us, minus 5 by 12 into cos x. Cos x we have calculated here, minus 12 by 13. And when you do the calculation, 12 we can cancel. And minus into minus, it is plus. We'll be getting as 5 divided by 13. I'm not showing the calculation because quite simply we can do 12 we can eliminate, and minus into minus plus, balance is 5 by 13. The next is cosec x. Cosec x is 1 by sin x, that is equal to 1 divided by 5 by 13. 1 by 5 by 13 is reciprocal, that is 13 by 5. Next we shall discuss the sixth question. There is another pattern of questions from here it is starting. Find the value of trigonometric function sine 765 degree. We are asked to find out the value of this sine 765 degree function. So sine 765 degrees, you can see here the unit given here is degrees. We know that all our calculations are in terms of radians. So this degree we have to change into radians. Simply multiply pi by 180. So sine into 765 into pi by 180. And here there is a common calculation is there, means 45 we can cancel here. 45 when you cancel, you will be getting as sine of 17 pi by 4. And here 45, if you are unable to identify the as a common factor directly, you can just go with simple calculations, like with the 5 we can start dividing, and you can just take as a rough on right side and do the calculation and write the final answer. Those who are good in mental calculation, directly you can take the heavy numbers and go for division, or else you can simply cancel it by using smaller numbers. So sine 17 pi by 4. So here 17 and 4 are there as fraction. Let's divide 17 and 4. 17 dividing with 4 means 4 4s are 16. Balance is 1. So this 17 by 4 we can write as 4 1 by 4. You can see here 4 1 by 4 mixed fraction. 4 1 by 4 pi. Again we can split this one as sine 4 pi plus 1 by 4 pi. The integral part we can take separately, that is 4 pi, plus the fractional part that is separate, that is 1 by 4 pi. And here we know that it is a multiple of 2 pi. And as we know that the trigonometric function values will repeat after every 2 pi. Means 2 pi, 4 pi, 6 pi, like that. So here 2 into 2 pi is 4 pi. Means the same value. This one we can consider as 0. Okay. This 4 pi value we can consider as 0, and it will be repeating the same value, means 1 by 4 pi will be repeating. So this one we can write as sine 1 by 4 pi, and as we have discussed before in the formula section, this 4 pi multiple of 2 pi means we can consider this as 0, and the value will repeat after every 2 pi, that is a result. So here directly we can write sine 1 by 4 pi. Then sine 1 by 4 into pi is 180 degree. Now we are changing this one back to 180 degrees. So sine 1 by 4 pi means pi just replace it as 180 degree. And here 4 and 180 degree we can cancel. When we cancel it is, I will show you a little bit. Here 4, 180 if we cancel, 4 4s are 16 and the remainder is 2, 20. That means it is 5 times. Means it is 45 degrees, sine 45 degree. So the final value we have got a sine 45 degree. And the table of values we know here 0, pi by 6, pi by 4, pi by 3, pi by 2. These are the values, and 45 means it is here pi by 4, that is 45. Here itself we can write directly answer by using this table. How do we prepare this table? That is very important. 0, 1 by 2, 1 by root 2, root 3 by 2, 1. These 5 values you need to by heart. 0, 1 by 2, 1 by root 2, root 3 by 2, 1. Then the same value we have to write from right to left in the second row. 0, 1 by 2, 1 by root 2, root 3 by 2, 1. Again, if you divide sine and cos, you will get tan value. 0 by 1 is 0, 1 by 2 by 1 by, root 3 by 2. 2 cancel means 1 by root 3. 1 by root 2 by 1 by root 2 is 1. Root 3 by 2 by 1 by 2. Here also 2 cancel, root 3 will be coming. 1 by 0 is infinity or not defined. So this table easily we can prepare. So by using this table of values and these 3 trigonometric functions, we can define all the other 3 trigonometric functions as well. Here sine 45 value from the table we can write it as 1 by root 2. 45 means pi by 4. This step is not mandatory, means converting this one into degrees, it is not mandatory, because some people are quite familiar with the degree units what we have learned in smaller classes, means class 10. If you want to go with that, then you use this one. If you are able to prepare this table directly by using radians measurements, from here sine pi by 4 directly we can write the answer. Sine pi by 4 is 1 by root 2. Next we shall discuss the 7th question. Find the value of the trigonometric function cosec minus 1410 degree. So here when we compare with the previous question, there is a negative sign here. Let's see what we can do. Cosec minus 1410 degree. First of all, this degree we have to change into radians. Before that, this minus we have to find out a solution. For that, we have learned a formula. Sine of minus x is equal to minus sine x. We have learned the derivation also, how this formula comes. Sine of minus x is minus sine x. Actually, this is cosec. The reciprocal of sine is cosec. So same effect will be coming for cosec also. Cosec of minus x is minus cosec x. Means take this minus outside and keep it in the beginning. So this one we can write as minus, we can bring out minus cosec 1410 degree. Now this degree we can change into radians. Minus cosec 1410 into pi by 180. And here, as I said before, either you do the calculation here or just write it on the right side. Do the simple calculations by using small numbers. Then when you do the calculation, minus cosec 47 pi divided by 6. Here 180 we can cancel with 30. Here both the 0 we can cancel. Then with 6 we can with 3 we can calculate divide here. Here 18 means 6 times. 6 3s are 18, and the same calculation here also can be done. With 3 if you cancel, 4 3s are 12, remainder is 2, 21. 21 means 47. If you want, I will show you the calculation how it comes. Here first of all 0 0 cancel, and with 3 if you cancel, 6 3s are 18, and here if you cancel 3, 4 3s are 12, and balance 2, 21 is 7 times. So this is the way we have got 47 here. 47 pi divided by 6. Then let's divide as before, this one 47 and 6. Why we are dividing means we have to write it as a sum of or difference of 2 pi, multiples of 2 pi. For that only we are just dividing this one. 47 divided by 6. 6 7s are 42. Remainder is 5. So 7 5 by 6. That is the answer. 47 by 6 is 7 5 by 6. But unfortunately here is an odd number. Actually we need a even number. Multiple of 2 only we need here. So we can make it as multiple of 2. How we will do, that is what we are going to discuss. This one we can split as 7 plus 5 by 6. 7 pi by 5 by 6 we can write as 7 plus 5 by 6. But here 7 we don't want. We want 8. So just to write 8. Then the denominator is also same. Just to write, then put 1 here. That's all. So when you do the calculation, 6 sides are 48. 48 minus 1 is 47. 47 by 6 will be coming. How we are doing? Just add 1 with the first number. 7 if you are getting means just add 1, you will get 8. And the denominator remains the same, and the plus symbol becomes minus, and the numerator it is 1. So 8 minus 1 by 6. When you do the calculation, you will be getting the same number. Now the first number is multiple of 2. So we take 8 minus 1 by 6 as it is even, because we want even number. Minus cosec 7 5 pi by 6. Actually this is the actual answer, but we don't want this one. We are splitting this one as minus cosec 8 pi minus 1 by 6 pi. This one we have considered 8 minus 1 by 6 pi. 8 pi minus 1 by 6 pi. Here 8 pi is multiple of 2 pi, that we can consider as 0, because after every 2 pi the trigonometry function values are repeating. That is minus cosec. This term only we want, because this one becomes 0 now, considered as 0. So 0 minus 1 by 6 by pi, that is minus 1 by 6 pi will be coming. That is equal to minus cosec minus 1 by 6 into pi, we are changing into degrees, multiply with 180, pi replace and multiply 180. Then here 6 and 180 we can cancel, 6 and 180 we can cancel, means 3 times 18, and the remainder is not there, so 0 we can put. That is coming as minus cosec minus 30 degree. That is equal to, this minus we can bring outside, because cosec of minus x is minus cosec x. When this minus comes outside, with this minus when it join, it becomes plus, so cosec 30 will be coming. Then that is equal to cosec 30 we don't want, we can just do it with a sine, because reciprocal of cosec is sine, 1 by sine 30. That is equal to, from here we can take sine 30. Sine 30 means pi by 6, so here it is pi by 6 value, that is 1 by 2. That is equal to 1 divided by sine 30 value we have substituted, 1 divided by 1 by 2. Then when we take the reciprocal, it becomes 2 by 1. 2 by 1 is equal to 2. Here also the same thing, directly we can substitute here also. This minus we can bring outside, cosec 1 pi by 6. Cosec pi by 6 means reciprocal of sine pi by 6. Reciprocal of sine pi by 6 means reciprocal of 1 by 2. Reciprocal of 1 by 2 is 2. Directly we can write from here, it's not a problem if you are able to do. Or else you have to go through these steps and come to the final conclusion. On to question number 8. Find the value of the trigonometric function tan 19 pi by 3. Here tan 19 pi by 3 we can just write as tan 6 1 by 3. How we have done means, just we have done the calculation like before. 19 we have divided with 3. 19 dividing, when we are dividing 19 with 3, it comes as 6 times. 6 3s are 18, and the remainder is 1. So this is the way we have written 6 1 by 3, that is written 6 1 by 3 pi. So tan of this 6 1 by 3 pi, we can write 6 pi plus 1 by 3 pi, just splitting 6 pi plus 1 by 3 pi. Here it is okay, because it is an even number, multiple of 2 pi. That is equal to tan 3 into 2 pi plus 1 by 3 pi. It's not necessary to write this step again, because directly we can consider this as a multiple of 2, and we can consider this as 0, no problem. That is tan of 1 by 3 pi. The reason is value of tan repeats after every 2 pi interval. So tan of 1 by 3 pi means tan pi by 3. Tan pi by 3 means tan of 1 by 3 into pi, we are converting into degree, that is 180 degrees multiplying. So here also we can cancel 3 and 180. 3 and 180 when we cancel, we will be getting a 60. Then that is equal to tan of 60 degree. Tan of 60 degrees, from here we can write 60 means pi by 3. Pi by 3 tan value, that is root 3. Okay, so that is equal to tan 60 degree, that is equal to root 3. And as I said before, from here tan 1 by 3 pi means tan pi by 3. Directly we can write tan pi by 3 is root 3. So which one is easy for you, that way you can follow it. Either in direct radians we can write the answer, or else convert into degree and write the answer. Which is convenient for you, that you can follow. It is not mandatory that you have to follow all these steps. Dear students, today we have discussed the sign of trigonometric functions, and we have solved problems from exercise 3.2. I request all the students to recall the entire trigonometric functions formulae and try to solve these questions independently. And while solving, if you have any doubt about the concept or about the method of solving, please note it and keep. We will discuss it during the discussion session. Thank you for watching.